When you frame a problem like this, it's not like you do it once and you move on. It is also iterative, right? So as users are interacting with the product and you're starting to get signals about, when the user is engaging, but, the metrics tell you that the quality is bad, there's probably a gap in the way that your metrics are characterizing the problem. So you're constantly improving the metrics, you're constantly improving the data collection in a production environment.
This is Deployed, the AI product podcast, and I'm your host, Ian Cairns, co-founder and CEO of FreePlay.
Hey everybody, welcome back to Deployed. We've got a great episode for you today with Kyle Nesbit from Google. He's going to tell you more in a minute, but he's been there since Chrome shipped, has gotten to work on the beginnings of BigQuery, was around when the Transformer paper came out in 2017, spent some time working at Gradient Ventures on the VC side, one of Google's early stage investment arms, and has been recently building AI and data features as part of the bigger Google Cloud BI effort, including their Looker acquisition. So this conversation is really fun. We're going to get into a bunch of just really brass tacks details, lessons learned from building over many years with ML systems of all kinds, including LLMs. But Kyle shares a bunch of good wisdom about what he's learned and things I think would be helpful to other builders. There's also some great stories about just lessons learned in the early days working with LLMs at Google. So hope you enjoy it. Thanks for listening. Hey everybody, welcome back to Deployed. I am joined here today with Kyle Nesbit, who is currently at Google, has been there for a long time, and let him tell you more about what he's been working on and who he is. Kyle, why don't you give us an intro?
That sounds great. Yeah, thank you for having me. This is actually my first podcast. So depending
Awesome.
on how it goes, maybe I will quit my career and become an influencer. I'm Kyle Nesbit. I've been at Google for 17 years. The first 8 years, I was working in high-performance distributed systems. My team and I, we built basically the backplane for BigQuery. So where we were doing all the distributed joins and shuffles and distributing query plans. That was a system we built. It was a massive undertaking, a ton of fun.
We've all used it or benefited from it. So nice work.
Thank you. And interestingly, it's coming back. Those type of systems are coming back in fashion with all of the need to scale up large machine learning clusters and being able to do high performance networking and RDMA, things of this nature has become popular. And I didn't think that would happen. Awesome. But after 8 years of doing that, I moved to Boulder, Colorado, spent 2 years in machine learning, doing machine learning ads. And then 3 years in Gradient Ventures, Google's AI-focused early-stage venture capital fund. Most recently, I have been working in Google's Google Cloud, Cloud BI, and data analytics org. Again, kind of going back to my roots, I sit next to the BigQuery team, but it mostly focused on integration of the Looker, a company we acquired a few years ago, into GCP and kind of building out its AI capabilities.
Yeah, I know we're going to talk more about that. Want to get into what you've been up to recently. I think one of the things that was interesting about having you on the show and having this conversation, you were at Google when the Transformer paper was published. You were at Google when Chrome launched. So you've been around, for a long time and seen a bunch of generations of this tech. I'm just curious to hear, and I'm sure other people are too, what was it like in the early days? You got to be hands-on early with LLMs after the Transformer paper came out in 2017. What can you tell us about your early experience building with these models?
Yeah, I mean, it was clearly a revolution. I can actually tell you a lot more about building with LSTMs and RNNs because they just required substantially more time, right? I recall we were actually doing a receipt scanning project where we were trying to parse receipts and understand what entities were on the receipts and how much those things cost. And we had these incredibly, they got to the point where they were high quality, but they required a ton of hand tuning, right? So a ton of feature engineering, a ton of just data collection and model error analysis to figure out where they're failing and how do we basically fill those gaps with other information, whether it's features or something else. And I recall when Transformers came through, it took a little while, I think, after the paper started, percolating around Google. But, within a few months, there were models that were available for everybody to begin experimenting and playing with. And they really just made everything incredibly easy. And, we were able to undo a lot of the hand tuning and feature engineering that we had done over a year or two. And in the course of a few months, they pretty much replaced all of the RNNs and other types of neural networks we were using for doing natural language processing at the time. On the flip side, I would say though that they've made it so easy to get decent quality that there's a lot of things, like there's a lot of ML fundamentals that I think we had back in the day and were super critical to getting decent quality that I see actually we're starting to miss, at this point, with LLMs kind of taking off. I think some of it is that there's a lot of folks that are starting to play with it that don't, it is so easy that there's a broader audience that's able to use the technology. But also with the ability, like the scaling that's happened over the last 2 years. I would say like the scalers have definitely dominated discussion over the last 2 years. More data, larger models, bigger clusters to train these things on. And the scaling has been incredible. But I do think, I keep hearing and I start to see some evidence myself that scaling era might be approaching the end. And so I'm actually, I like engineering. I like building stuff. So I'm actually looking forward to going back to the day where, some really good engineering and hand tuning is the key to making the difference between an okay model and a great model.
Interesting. Do you have a vision of what that looks like? You've talked about like how LLMs have made it so much easier, taking away that kind of work. Like when you think about that horizon where the tuning really matters, do you have an example use case in mind, or is it just more of a
I can talk a bit about the data use cases that I spend most of my time on.
Awesome.
For example, like, and this is not a project that I work on, personally, but I see a lot of people working on it. Natural language to SQL, right? I think early on there was a hope that you'd be able to just grab a bunch of schema, give the LLM a prompt, and it would spit out the right SQL. And I think across the industry, we're seeing that there were some great improvements early on. Like there was this like natural language SQL performance kind of took off, but it's we're seeing it starting to plateau. And there's going to be some workloads, really critical workloads, where people are going to want to use a technology like natural language SQL, and it just won't have the quality required to support that use case. And so that's the place where I do think that some really crafty engineering, possibly RAG systems, some very specific kind of intent analysis and prompt engineering, like kind of more old school, roll up your sleeves and really hyper optimize for a specific problem. I think those types of those things are going to be required again and begin, to have more impact than they have over the last 2 or 3 years.
Yeah, that's interesting. Like it might be the function of where you sit, but you talked about wanting to get back to the world where, some hand tuning of these systems actually matters. And then you mentioned prompt engineering. So it's very different from like the feature engineering you're doing with RNNs. Is that what you had in mind? Like what changes about the tool chain when you're working with an LLM, when you think about like what just practically is going to go into that kind of system tuning you're describing?
So I actually, personally, when I think of prompt engineering and feature engineering, I actually think of them as being the same, right? Like I think back in the day when we would do featured engineering, it was you needed to, know Python, we use TensorFlow, which is like incredibly low level, take a tensor, right? Be able to, get the tokens out of it, be able to do a one-hot encoding, and then stick it into like a neural network, right? That was like the level of feature engineering. But at the end of the day, that whole process was just bringing a specific type of information that's in the ground truth data, like in your input data, to the model so it can make a better prediction, right? I see prompt engineering as being very similar in intent, right? Where it's, maybe I do some model error analysis and I see like there's a pattern that this LLM continues to misinterpret, like a statement like, plot this as a percentage, right? And it turns out that what the user typically will intend when they say as a percentage is you should plot it as a pie chart, right? So in a case like that, what would you do like with prompt engineering? You would recognize, percentage means pie chart, and then you would just inject into your prompt that additional bit of information that if the user says percentage, generate a pie chart, right?
Sure. If the model doesn't even do that by itself, right? Like
that's right. But that's very similar to like the way feature engineering worked in the past, where you do model error analysis, you'd see like a class or a pattern of errors, and then you had to basically introduce more information for the model to be able to predict that case correctly.
Yeah, that makes sense. And like we're kind of getting into that use case. That's a good example of, I think, what you've been doing on the BI side when you talk about like you've been working recently on AI and data at Google. You mentioned the Looker acquisition, but maybe if I like pull back up a level just to give people more context, as a builder working on product within Google, like what have you been up to? Help us understand, like, what does that mean when you talk about data and AI? What are those projects and what are customers doing with what you're building?
Yeah. So, I mean, there's tons of things that customers are doing. There's tons of appetite to apply AI to data. I'll talk about the thing that I've primarily been focused on though. And if you've got questions on the periphery, I'm happy to answer those as well. But the thing that I'm super passionate about and excited about is a concept called semantic data modeling. And basically what it means is you take some data in its raw form, and you transform it into a representation that's familiar to the user. Typically this, shows up in businesses. So typically it's like a business analyst or business user where they might not understand the data if it's sitting in the databases, distributed across the enterprise and it's like operational form. But if you can translate it into the dimensions that they're familiar thinking about with respect to the business, the metrics and the measures that they're familiar thinking about, like all of a sudden, right, that user is able to get a lot more value out of that data. This concept of semantic data modeling has been around for like 20, 30 years. Like BI tools, the consumption layer of BI tools, our visualization layer, has sat on top of these semantic data models for a long time. And I think they're becoming even more relevant in the era of AI, because it's a case where not only are people going to want to visualize things, with respect to dimensions and measures that they're familiar with, but they're going to want to like chat their data. They're going to want to use natural language terms and be able to do much more flexible, less rigid kind of analysis on the data or on the semantic data model than people have done in the past. So that whole thing is really what I have been focused on.
Yeah, no, that makes sense. That's why you mentioned text to SQL and, trying to figure out what kind of graph to use when somebody asks for a percentage. Like, is this stuff, if people are a Looker customer, is like alive in the application today? Like an analyst can go in and, ask these kinds of questions and do that semantic modeling?
So absolutely. So we recently announced LookML Assistant, a project that I worked on. And it was actually the thing that allows you to generate LookML. LookML is the Looker semantic modeling language. It's really one of a kind in the industry. But then there's also projects that we have conversational analytics, and that's kind of the top half, right? Where it's not going to be somebody like a technical person doing data modeling. It would be somebody that is asking questions of their data. And by having that semantic model between that business user and the raw kind of, the raw operational data has proven to provide much higher quality than is possible if you just try to do it end to end.
So, you're talking about like what you all are doing with Looker, makes a lot of sense. You're working on text to SQL and related problems that some people listening to this podcast will be familiar with. We've had people on before. They've even talked about trying to solve some of those challenges and even given up and decided to just go a different route, rather than, do a text to SQL lookup, just like provide a tool call with a common query and just know that the call is going to work every time. So like, I think that's at least one common challenge people have run into in this space. But I'm wondering, like, what's some of the other, just like people that are listening and wanting to learn from experience, what are the practical kinds of problems you all have had to work through? Is there anything you can share about, like, hitting dead ends or like the ways that you solved some of the hard problems in here that just might be interesting to other people building in this space?
Yeah. So, it's interesting the way that you frame this. I think, when we've done ML, at least when I've done ML at Google in the past, we focus on a problem that's so important that we're going to solve it. And even when we feel like we've hit dead ends and that, it's not as easy as we had thought, usually there's conviction that it's an important enough problem that we're going to continue to invest in it until we crack the problem. And I really
like the benefit of working at Google. You get to work on amazing problems that way.
Yeah, but I think this is also just like, like ML was just expected to be this way. It was almost, the way I kind of think of it is, it's almost like drug discovery, where like you show up at work, you work hard for a very long time and you show almost little progress. And then one day there's like a huge breakthrough, right? And now you've got a new drug to go to market with, right? That was just kind of the expectation, right? For people that were doing machine learning. And so I think part of it is like, you don't give up. And I do think in this current wave of AI, people have like just kind of gone around. It's kind of a gold rush, and like just dig a hole, really shallow holes, and nobody gets deep enough to find the gold.
Interesting. Yeah.
So I think that's part of it. The problems that I think that are really common in the natural language SQL case in particular is again, hallucinations, right? Even if you give the LLM, here's the query, a natural language description of the query you should generate, and here are the columns you should use, it will hallucinate its own columns, right? And so a lot of it, I think, is around just, what I typically see across the industry is that people have really had to put up some pretty significant guardrails around these things, right? Using templating and other techniques to like give the LLM something, and then, when the LLM responds, be able to parse it and validate that, yes, this is, roughly shaped the way that I expected it to come out. And I've heard this across many enterprises, many companies, right? That everybody is really, really putting up these pretty significant guardrails, in many ways constraining the potential of what an LLM is capable of doing. So there's another whole class of research of like, people that are trying to get further out to say, well, how can we really get rid of all the guardrails and really let the LLMs run unconstrained, but still provide the quality that's required for, the use cases it's being applied to.
I feel like you get to see more of the future than maybe some of the rest of us do working within Google. So know that there's only so many things you can talk about. Want to respect privacy, but are you starting to see like a horizon there? Is there some set of techniques or other approaches that are looking promising that way? Do you think that we're close, or what's your take on when we get there?
For fully unconstrained, for what it's worth, so we do see a lot at Google, and I think a lot of it comes down to just interacting directly with customers, that are coming to a large public cloud provider. At least given my spot within Google. But like the really kind of, aggressive, forward-looking stuff actually is not, they don't sit very close to me at Google, right? They're more in the deep line part of their organization, not necessarily in the applied portion. And so the techniques that I'm most familiar with are actually the ones that people are talking about, like in kind of, venture circles.
All of us are talking about, yeah.
Yeah. So there is nothing specific to Google. But I have seen some pretty interesting, like reinforcement learning techniques, right? Where as the user is interacting, there's a signal that's going back to the system that, yes, the models are on the right track and are able to kind of close some of the performance gap or some of the quality gap and allow the user to at least get a sense of a higher quality user experience because it's constantly learning as they interact with it. Those ones are really exciting. There's a paper that was forwarded to me recently from MIT where I was like, that's really exciting. I haven't seen a practical application of how well it works, but the papers look great.
Yeah, that's interesting too. Like, I'd be curious your take. I think, we talk to a lot of people that are, let's say like ramping up with their use of LLMs in large scale production environments. I think there's still, it's decreased recently, but there's still some, initial instinct. People are reading about the space. Maybe they've been doing like more traditional product engineering and, they hear about reinforcement learning and wonder if it's for them in their like applied use of LLMs within a chatbot or another product that they're building, something like your Looker ML chat, or, configuration chatbot. Like, is there some use case that you've seen where your enterprise customers are getting value out of reinforcement learning that's actually working in an applied scenario?
I've not seen that personally. And I think there's a lot of these really interesting techniques that people are talking about. And even some of the more aggressive, like agentic use cases, right? What I always tell people is I'm a firm believer in you optimize what you measure. But conversely, if you can't measure it, you can't optimize it, right? And so I really think the limit of like any organization's ability to use some of these advanced techniques is their ability to measure whether or not they're good, right? And when you get into like, multi-turn conversations, like agents that could possibly, explore very large space and take a user into a quarter that you haven't thoroughly measured or evaluated, I think, my sense is that, through kind of like UXR and testing of those things, they just aren't able to use those super, super advanced techniques. And this is where the guardrails come in.
Well, I think you're getting into the space. It's like, I think a lot of people listening to this are dealing with similar problems, challenges. Like you're touching on guardrails and evals and, figuring out what to measure different parts in your system. Like what have you developed as kind of the core toolkit, or, is there some set of tools or workflows that have become like just a effective way to get to quality outputs that you can talk about?
Yeah, for sure. I mean, it's interesting how I've seen most teams at Google do machine learning projects and eval compared to like how folks do it outside of Google. Yep. And I think the big difference is that Google is a very vertically integrated company, right? So it's like we've got maybe one or two ways to do a specific thing, right? And those things are very well supported. And they work with every other kind of piece of the tech stack. So when you want to do a machine learning project, turns out you can actually use most of the infrastructure that was built for like Google's initial indexing pipelines, MapReduce, Flume pipelines, right? Our distributed file systems, Colossus, right, for storing inputs, intermediate results. Then we've got incredible, visualization tools that are used across the business for all kinds of different uses, right? But all those things work so well together, and our workforce is really, really capable. And so typically we don't. I mean, there are a couple of cases where there's like an end-to-end solution for doing something specific, but I would say in most cases, engineers are basically just stitching together solutions based on all these well-integrated components. And then what you see often is that teams will then begin to gravitate towards, common patterns, right? So like, for example, a machine learning eval pipeline, I've probably built one of those. I've built at least 10 of those, and they look all the same. The only thing that's really different is the metric portion. And so you see basically these patterns emerging, and then naturally they become, easier for other teams to kind of replicate for their specific problems. It's quite a bit different than like the outside world, right? Where, and for example, something like free play provides a ton of value, right? Because just that integration overhead, you've got 10, 20 solutions for each one of the problems, which is the right one, right? And then for each one of the specific problems they're solving, having to go and have engineers actually do the integration and get, the round pegs and square holes to line up is a substantial amount of work and investment. And so that's what I think is like the biggest difference that I see, not just for, machine learning and eval, but really across the board in the way that we build things.
I appreciate the shout out. We're definitely not going to correct you. Definitely the problems we're trying to solve, but like you say you've built, an eval pipeline 10 different times. The only thing that's different is the metrics. If you were to do your like kind of break down the process a little bit more for people that are listening, and I think a lot of folks honestly are in a place where they're saying, hey, we know we need to be doing more with evals. We're ramping up in this space. Haven't done it 10 times. Walk us through an example or like share some advice. What would you be thinking about? I've done this 10 times. Here's what it looks like if you want to go do it for yourself.
Yeah. So I would recommend folks, if they're really interested in this area, I would really recommend folks look at a paper called TFX, TensorFlow Extended. It's not our latest generation of like machine learning pipeline within Google, but it has established like a lot of like the best practices in terms of how do you build production grade machine learning pipelines, right? And there's a few things. One, I think the most important thing is when you start a machine learning project or like an LLM project, you start with your evaluation, right? You start with what's the problem formulation, right? Like, what are the inputs that my model will get in production? What will the outputs be? How is that going to drive like a high quality user experience? How do I characterize, both my input data is good and my output data is good, right? And so it's really, this is not even really engineering. Well, there's some kind of mathematics, but it's not really like software engineering at this point. It's just framing the problem, right?
We've talked about this. It's almost like a social science problem sometimes, right? I think there are people that do social science research who get really good at like designing a survey and breaking down into like very structured forms the way that you describe what's going on. And tell us more about that part of the process. If it's not an engineering problem, how do you figure out what those elements should look like?
So it's actually experimental methodology, and like you can go, and I think it's closely related, like it's closely related to statistics, and you can go get a PhD in experimental methodology. In fact, when I was working on our ads team, there were a number of people that specialized in experimental methodology, and all of the principles apply, right? Like, how do you make sure you're sampling, surveying in a way that eliminates bias or reduces bias, right? And it really depends on the product, but I think a lot of Google products, we really try to get our data set from real world traffic, right? So when we're doing that problem formulation, we're not just thinking about, okay, well, how do we build the evaluation, but how do we really start the data flywheel where, once we have this product up and running, yes, we've got a user experience that's going to have click-throughs or some type of engagement, right? That helps us validate that, yes, the user is getting value out of this. And then we can use that to feed, the ground truth and to feed the evaluation and optimization of the model. I would say those are the high level bits. I think especially in the world of LLMs, being able to determine what's a good and bad output on unstructured data is a really hard problem. It's very subjective, right? It usually often requires humans, right? You really do want to think about that overhead and that human cost up front if you're going to go down that path. But one of the other things that I would say, like I do work a lot on like natural language to code problems. And it turns out the output's not unstructured, right? It's code, right? Code is structured. Yes, it's text, but you have to parse it to get the structure out of it. And once you get the structure, it becomes actually much, much easier for you to figure out how to kind of quantify what's good and bad about that snippet of code. So those are the types of things like that you really, you tend to spend a lot of time, up front. Right. So once you kind of frame the problem, the other thing I would say is like when you frame a problem like this, it's not like you do it once and you move on. It is also iterative, right? So as users are interacting with the product and you're starting to get signals about, when the user is engaging, but, the metrics tell you that the quality is bad, there's probably a gap in the way that your metrics are characterizing the problem. So you're constantly improving the metrics, you're constantly improving the data collection in a production environment. But the basic, if you look at like the TFX paper, once you've done the problem formulation, ideally once you've got, data flowing in from production, data usually gets dumped into Colossus, our distributed storage system. It goes through a stage of pipeline phases where, we are evaluating the model on the latest data or on the latest data that we collected from production. But there's been a concept covariance shift, right? Where like the input data to your model is actually changing constantly, right? And so you need to be constantly evaluating your model to make sure that, your last eval was representative of what is running in production. So typically there'll be these pipelines will run some type of evaluation. they will, go and optimize a model based on, some holdout set that again is coming in for production, so that, not only have we evaluated the model shipped to production on the latest data, but we are also constantly optimizing the model on the latest data. And then, once that whole thing goes through, we'll do an evaluation of the latest model. And usually there's a validation step, which is, the metrics that I've defined, is this model within some tolerance, either better or within some tolerance than the previous model. And if that check passes, it's almost like a CI/CD pipeline. The latest model pushes, production starts being served. Not all at once, but incrementally across all the data centers that are serving.
There are so many practical things I'd want to ask you about in what you just said, because I think we get questions about this workflow all the time. And like, maybe to pick a couple of them, one is you just talked about like how iterative it is to kind of get to the right evals and make sure you have the right metrics, and like you learn things and you need to adjust. Give some color to folks for like, how do you decide to do that? I've had people go to the point of saying like, hey, we're used to running a traditional software sprint. We know all of our ceremonies. We know how we're going to like incorporate bugs and feature requests and other things. We haven't really figured out what our cadence should be for how we like reflect on what we're learning with our LLM pipelines and decide when to adjust our evals, and how do we decide when it's worth it. For people that are kind of like asking those sorts of questions and trying to figure out like how you actually run a team and run a process where you're building high quality production software with this tech, what would you offer as advice in that area? Just like practicalities of, iterating.
So I think it's actually really easy, but I think you need to have support from leadership. So one of the things that I've noticed recently as AI has kind of permeated all aspects is that leadership, like the leadership that's running software engineering teams, large software engineering teams, are not used to this iterative nature, right? They are, I wouldn't say that it's waterfall, but they are, they do want to be able to have commitments to customers, right? And be able to make sure that they deliver on those commitments. And when you go back to them and you say, well, we're just getting into this machine learning problem. There's a lot of unknowns. We're going to iterate, and we cannot give you a firm date when your quality threshold hits a mark. I mean, there's definitely, there's some challenging kind of stakeholder management conversations that happen.
It's a big cultural shift.
Yes.
I mean, even if, like you said, if it's not waterfall, people are at least used to building software, or once you ship it, it kind of works until you break it or you make some fundamental change, right? Not this progress toward it just always working a little better.
But with that said, like if you can crack that like large organization problem, you can create a culture where, yes, it's more like drug discovery. There's going to be uncertainty. I think it's actually much easier to run like an ML engineering and software engineering team than it is to run like a typical product team. And the main reason why is because you eliminate like all of the different layers and different people, right? Once you have, aligned with your stakeholders that these are the right metrics to capture whether or not like our ML system is performing well, like you need to do that upfront with your stakeholders. But once everybody's aligned on that, right, then the engineering team basically is just in an iteration loop where all they are doing is focusing on those metrics, right? And, finding optimizations and techniques to keep those metrics going up and to the right. And if things are going well, right, they are going up to the right, and the executives see their dashboard and they see the lines going up and to the right, and so everybody's happy. It's like a win-win. But I do think, it does require, like for a typical software engineer, it requires like a cultural shift. But there's lots of teams within Google that have been operating on this model for a while, where it's very natural and very effective.
Just like super brass tacks, I mentioned this before, but are there ceremonies or some kind of like review cadence that you've seen work in a way where it's like, oh, that feels right, really helpful for a team that's building in this way? I think if I were to make the comparison, like a lot of people know they're like agile sprint planning ceremonies, right? They have their ceremonies for reviewing customer feedback and grooming bugs or whatever.
Yeah.
How do you run a a cadence where people can improve these systems consistently?
So I think number one is it is that dashboard, right? Like having a dashboard that captures, the quality metrics that the team has aligned on, right? And really focusing on everybody on the team on making those metrics go up and to the right, right? I think that is number one, right? Like it really sets the goalpost, it really frames things. I think that's the most important aspect. The other ones though are, you should have, and I think actually, most of the machine learning that I've done, like roll up my sleeves machine learning that I've done has been in person, right? And it is incredibly helpful to be able to, interact with a colleague like that's working on a similar part of the problem with you, to talk about like an insight that you just got out of, an evaluation run or error analysis run, right? It really creates like a very lightweight, rapid iteration kind of workflow. And for what it's worth, even in person, I saw that like you could only really have 2 or 3 people working on a specific aspect of model quality at a time, just because, it does require such like synchronization that as soon as you start to scale up, things will become less efficient and like people will get out of the loop, right? Now, in a distributed workplace, you really have to lean on chat, right? And you really have to be quite pragmatic around every experiment that you're doing. You tend to have to document it a little better, right? And have a forum in which you can broadcast like an evaluation run, right? So just take a link from your latest evaluation run, put it into the chat or some communication forum, and describe like what you learned from it, right? And then that's another way to kind of keep people in sync, even when they're not sitting physically right next to each other. And then I still think you do like the typical kind of, I typically would do like a two-week iteration, 2-week sprint, where you really do want to focus a lot on the retrospective, right? And just sharing of the things that were learned throughout that last 2 weeks, so that it's like an even playing field and everybody can jump in and, do the next level of optimization required for the next week.
Yeah. And so you still are planning that way.
Yeah. I think, I think if you look at like the two, agile development and the 2-week sprint, like it was kind of that iterative process that it was, built for.
It works.
It drifts, I think it's drifted quite a bit in the last decade or so, the way that people apply sprints and agile software development. But if you go back to the basics, I think it actually works pretty well.
Yeah. I think that part of why that's even a question, it seems obvious in some ways. We've seen a good cluster of people that feel like, when you get into this space where, you see an issue in production with what an LLM is doing, and you can like pinpoint, where that, like which prompt it is in your pipeline that's causing a problem. It's really tempting to like just do some quick prompt iteration. It's just like, it can be deceptively fast. And then I think what we've also seen is people end up getting sucked into the temptation to, see a few different things failing and want to fix them all at once. And, you quickly kind of like get pulled out of that sprint mindset where you're prioritizing this and not that. You did just talk about that a little bit, right? You're like, hey, it's helpful to have no more than 2 or 3 people focusing on one aspect of a system at a time.
Yeah.
If you see like multiple evals failing, multiple parts of, whatever quality looks like that aren't meeting the bar, how have you gone through kind of like approaching making the whole thing better, right? Like, are you tackling one thing at a time? Are you tackling multiple things at a time? Do you fan out? Like, tell us more about how you handle those situations.
Yeah, so I think it does go back to metrics, right? Like when you think about like these dashboards that a bunch of people are tracking to see whether things are going well, you really do want 1 or 2 top line metrics that people can monitor to say that's good, right? But the reality is that there's usually like 100 different slices, right, of the space, where like the performance of the model actually matters varying degree for those different slices. So I'll just give you an example. I mentioned the receipt parsing project that I worked on. Yeah, I mean, if there was like a small mom and pop shop where all of a sudden our receipt parser did poorly on, right? It was bad. It wasn't good, but it's very different than Walmart's. The quality of the Walmart parcel went down, right? And so you do also need to not just have the top level measures, right? But have visibility in the entire space that you're trying to optimize for. And then have not necessarily something has to be 100% quantifiable, but at least within the engineering team, have a way to prioritize, right? These like different conflicting kind of quality goals and requirements. And often that's actually like a product requirement process where you actually need to pull product management in to say like, okay, like we've got all these fires, which ones are the most important in terms of providing the best quality for our end users. Okay. But then even in cases where it's like, okay, I can make this metric better on this slice, or I can make that one better on that slice. And you really do need somebody, product or UXR, that has like enough understanding of the use case and the customer and the consumer to be able to make, to help the engineering team make those judgment calls.
Yeah, no, that tracks with, I think, where we're seeing the successful teams, right? Like maybe a third of free play users are in those kinds of roles, product design, some kind of analyst role where they like really know the customer. And that's often the role that they're playing, right? Like they're thinking about, do we have the right evals? Let me see the experiments. Let me get a sense for what the scale of the issues are, the anecdotal, like qualitative nature of those issues, and then helping a team prioritize launching those experiments. I think one of the practices, I'm kind of curious to get your take, but we're seeing more and more teams gravitate towards is like when you see a bunch of metrics failing or not being where you want them to be, just picking like one metric at a time to go after and not trying to do a bunch of like multi-dimensional improvements. Sounds like that's kind of where your head's been, but like, does that track with what you've learned, or do you think about it differently?
Yeah, typically, right? I mean, typically it is, and there's all kinds of stuff actually in BI. Like you find the key drivers for a metric, or you find an anomaly, right, on a region of they call it an OLAP cube, right? And then you really focus on solving that problem in that case. And many times what you do to solve that specific anomaly, those techniques will actually make quality go up overall, right? But not always. And this is where you run into trade-offs. I think the one thing that is really important is that regardless, like you've got a data set where you're comfortable that you actually have full visibility. I think what you mentioned earlier, where somebody says there's a quality problem, right? And then people are running around trying to fix it. Often the way that I see in startups at least today, it's like that quality problem is just a customer, some customer report, right? That here's my one example of a case that I'm not happy with, right? And then people go and they try to fix it. But I think you really do need to treat it like, again, like kind of software engineering, where it's like, okay, in a good software engineering team, when somebody reports a bug, what's the first thing you do? You write the test, you reproduce the bug, right? Because if it's a bug in production, like you don't have a test for it. So I would say like the first thing would be to do is to take that customer's use case and put it into your ground truth data, whatever you're using to evaluate your models, right? And then also trying to gauge like, can this be generalized? Is there a bigger gap in our data that this is pointing towards that we can fill, right? So I would say that's step one. And then if you do that consistently, your data set will become better and more representative. And then, once you're into that mode, right, then you can begin doing the evaluation and getting, going back to this place where, yes, you've got a bunch of quality problems across the board, but you've got kind of a framework for how to prioritize those and how to begin burning.
Yep. And maybe that leads to my last question, this like space of just the brass tacks details of building. But you mentioned one other part in your process, which is kind of like that last step of how do you do something like CI/CD, like run validation checks, and if it passes, decide to ship. I think that is one where we've seen a lot of people scratching their heads too. Like, what's the right threshold? If we're at 89% versus 90, why is that the threshold that matters, if we're deciding to ship? You can imagine like the space of questions there, if they're like, things are close, right? Like
Yeah.
Just curious to hear you talk about what you've seen, like those validation decisions look like, and when it's felt like, hey, we're getting lost in the weeds here, too much focus on the metric versus finding like a good operational or like operating point where you just decide this works, let's keep moving, like we should ship it. Would love to hear your thoughts in that space.
Yeah, and this is why I say like you're constantly optimizing your quality metrics. Like you should have metrics, right? You should go through the CI/CD like pipeline, and when your metrics prevent a push, right, you should stop and you should look at your metrics. Like you should say, did the condition that caused this push to fail, is that something we truly believe is going to impact like our customer experience? And the way that I think about it actually is it's based on my background at Google when I was doing just large distributed systems. And it's very, very similar to, tuning thresholds for your monitoring, right? Where it's like, is the 99% latency over 5 seconds? Like we've got an alert that says it triggered, it woke me up in the middle of the night. But is that the right threshold? Is that the right metric that we believe is directly correlated to that user experience, right? And often if you're running like an operational team, like an on-call team, right, over time, you're doing a similar process where you're adjusting all your metrics and your thresholds to get to the point where your users are happy and, you're not getting woken up in the middle of the night, right? I think this is the exact same thing that I apply to the quality measures. It's like every time, you want to have these guardrails in place. You want to have the visibility, but every time there's like some type of toil, right? You step back and you look at does that trigger still make sense in the current context? And when I ran engineering teams doing distributed systems, you want to do it like you want to have like a biweekly retrospective where you look at basically all of the things that have fired over the course of the 2 weeks or quality issues that have come up. And you go through this process of, okay, is that threshold correct? Should we relax the threshold? If it is correct and it's an issue, then how do we prioritize that and get somebody to work on it this week so that we don't have to come back to that biweekly meeting and have the same conversation?
Yeah. That's great. I mean, I could keep asking you these questions. I think these are the questions that free play customers are asking, all day long, trying to figure out how to really operationalize this stuff. Thank you for sharing it all. I know we're going to run out of time soon. So like, if you think about the future and, the things we didn't talk about, maybe like one transition question, what do you feel like, people who are building in this space are just like not thinking about enough today? And where is there like conversely too much hyper focus that's not worth it?
Yeah, so I think the place I think there's huge opportunity in this thing is foundational capabilities, right? Like, so clearly I work a lot with data. And that's really where I think about how to apply AI. But the biggest problems, and we've heard this from UXR, the kind of the business intelligence, organizations in the world have heard this for over a decade. The biggest problem in BI today is discovery and access to data. And it turns out like putting, a chat your data chatbot on top of existing data warehouses and the existing data silos, like it's not going to solve that discovery and access problem. And I think these types of things are like huge opportunities because depending on, where we are at with respect to the hype cycle, if you solve those foundational problems, you're going to bring value to these businesses. And so if the bubble does pop, right, you still are in a place where you're providing durable problems. They're just not the AI hype ones that people were excited about 6 months ago. So I think foundational capabilities, like, if you ever see like some type of foundational issue that's preventing you from realizing as much value as possible out of AI, fix it, right? You're going to provide value and it's durable. That's great. Where I think there's too much hype, and I actually think that this is like it's starting to go down a bit, is demos. AI demos are almost worthless, right? Almost all AI demos that I've seen are marketing. But the thing that's hard is like, if you are out trying to pitch your new idea or, pitch a product, it's really hard to talk about AI without a demo.
Yeah, you got to show it off. Sure.
Right. So, it's very interesting. As I've chatted with people recently, it's like, I'm reluctant to show AI demos because I know like everybody at this point is kind of skeptical of a demo. But at the same time, I simply cannot communicate like what I'm thinking without the demo. So, I kind of would like to see that trend continue where people really only bring out the demo when it's for communication purposes and not to try to show off some magical, some secret sauce or magic that they've got.
Joining two thoughts, you're kind of making me think about, like, I think part of why we would both say and agree that a lot of the times the demos are just not real, they're just for marketing purposes. You made this comment earlier that, lesson learned through the years, start with your evals, start with like what quality is going to look like, really go after that. I wonder what the point's going to look like in the ecosystem where people start leading with the evals and the metrics to go with the demo. That feels like a bar that will be healthy when we hit it.
So I encourage everybody that listens to this, like if somebody pitches you something related to AI, I would ask them, how are you measuring what's good and bad? This is advice that I've given to a number of VCs, just because I was in the venture community for a while, people still reach out to me on diligence. And I tell them, just ask them that question. And if they come back with an eval that's like well principled, well thought through, and the results are bad, invest, right? They know how to measure the problem, they'll optimize it, they'll figure it out. But if they have no idea, like how to even collect the data, how to quantify what's good and what's bad, right? There's no way that it's going to, in my perspective, there's no way that will.
That's a good bit of wisdom. Feels like a good place to stop. Kyle, thank you for sharing everything you have today. I know a lot of people will appreciate it. It's great talking with you, and look forward to the next time.
Yeah, sounds great. I got to keep my influencer, career trajectory going.
You just got a bunch more clout points today. I'll leave that as an Easter egg for whoever's watching. Thanks so much. Have a great day.
You too. Bye.
All right, that's all we have for today's episode of Deployed, the AI Product Podcast. I'm Ian Cairns, the CEO and co-founder of FreePlay. I hope you enjoyed listening. And if you did, we'd love to hear about it. Your reviews mean a lot. They help other listeners. So give us a like, share, subscribe, wherever you're listening to this. And if something stood out to you in the episode, or if you've got feedback or ideas for a future episode, or if you simply just want to learn what we're up to at FreePlay, shoot me a note. I'm Ian at freeplay.ai. You can also find me on Twitter @Cairns. Thanks so much for listening.